All right, so this unit we're talking again about probability. Last time we did probability, we did experimental probability. This time we're going to be working with theoretical probability, which is a little harder to calculate, but used in different kinds of situations. So just to remind you, like probability, what it means, usually we either express it as a percent or a fraction. So for example, 50% chance of something happening, or like 1 out of 2 chance of something happening. We also do odds. We're not going to talk about odds that much because it only happens basically like when you're gambling. So probability is a way of expressing like how likely is something to happen. So the way we do it is this fraction. Okay. So basically it's like good events or good outcomes divided by possible outcomes. Sorry, pen's being weird. Possible outcomes. So for example, if we're flipping a coin, okay, we're going to do our fraction just like this. Let's say that I win if it's a heads, okay? So there's only one good outcome if I flip a coin. If I get the heads, that one outcome's good. The possible outcomes, there could be heads or there could be tails. Because there's two, my fraction's going to be 1 out of 2. That's my theoretical chance of getting a win, of getting a heads when I flip a coin. Now, when we did experimental probability, basically what we meant was we would do an experiment and see what we get. So for example, if you flipped, I don't know, 5 coins, our total would be 5 flips on the bottom, and however many heads, let's just say we only got 1. Then we would say, wow, our probability was only 1 out of 5. This experimental probability is only really good when you're doing stuff that isn't random, like a coin flip. So for example, if you're doing something like medical research and you're testing people, that would be a good example of experimental probability, because it's not always the same medicine in different people. There's all these factors, so you have to do an experiment. Another one you could do would be based on like people's preferences, and you want to figure out what's the probability that I'm going to talk to someone that likes, I don't know, Facebook instead of Twitter, or like red instead of blue, or whatever. But if you do something like a coin flip or a spinner or a dice, okay, where it's random, these kind of events are better for theoretical probability because we can basically calculate how many of the times should each outcome happen. So the basics of probability, this fraction we just talked about, is pretty straightforward. Let's do another example just so we can kind of see. So if we look at like spinning this spinner, okay, so it has like an arrow, and then you spin it and it points towards a number, 1, 2, 3, or 4, or a color or whatever. We have to make a fraction. So let's say, what is the probability of getting green? So when I look at it, there's one good outcome, which is green. There are 4 possible outcomes. You could get yellow, blue, red, or green. So our probability would be 1 out of 4, or if you wanted to turn that into a fraction, you do 1 divided by 4 times 100, and it would give you 25%. Okay, same idea. That's review stuff. Now, like we said, percent. We could also calculate the probability of like dice. Okay, so let's say we're playing a game and we really want to calculate. We really want a 3. Okay, that's what we want to roll. So we're going to say, what are the good outcomes? Well, there's only one. If we get a 3, that's a good outcome. Any of the other numbers are bad. And then we have to say, okay, well, what's the total possible number of outcomes? Well, a dice has 6 sides, or at least the normal ones do. So our probability is 1 out of 6. That's the basics, and I think most of these are pretty straightforward. You could make different situations. So for example, if you have a spinner that has, that was bad. Let's do 8. If it has 8 sections instead of this, and let's say it was colored in this way. Okay, let's say we wanted to say what is the probability of getting yellow. So we need to say, well, looking at yellow, there's 3 sections that are yellow, and then for blue there's 5. The total number on the bottom is 8 sections, and 3 of them are yellow. That's my yellow probability for that. Okay, these get a little more complicated when you have multiple events. So for example, if you flip a coin 2 times, be very careful. We're still going to write this as a number over a number. Okay, but we need to do a little bit of extra work. So for example, let's do this. what are the odds that I will get 3 heads in a row? Okay, head, head, head. So I'm going to actually draw out a chart to show what happens. So the first time I flip, I can either get a heads or a tails. Then I have to flip again. And after I flip that heads, I can either get another heads or a tails. We have to actually draw the other side, even though we want 3 heads in a row. So on this side, we could also get a heads or a tails. And then for each of these flips, for our third flip, we could also get a head or a tails, a head or a tails, a head or a tails, a head or a tails. So this was the first flip, the second flip, and the third flip. This is called a probability tree, and it helps when you're doing more than one event, more than one thing at a time, flipping more than one dice, spinning more than one spinner, rolling 2 dice at a time. So when we look at this, the question was, what are the odds of getting 3 heads in a row? So that would be if this happened, head, head, head. So these at the bottom are all of the outcomes. So let's write our probability. How many of these at the bottom, these are like the final answers, were our good ones? Well, 1, because this one at the bottom was when we got triple heads. What about this one? Because this one means we got heads, and then a heads, and then a tails. So that was another outcome. Or we could have gotten heads, and then a tails, and then a head, or a head and then a tails, and then a tails. So when you look at it, there were 8 possible answers at the bottom. There was only 1 that was good. So our probability in this case of getting triple heads is 8. Now let's do it again, and let's say what are the probability of getting just 2 heads? Okay. How many possible outcomes are there? Well, there's 8. Now to figure out how many times we can get 2 heads, we might have to actually like count through and look at them. So let's look at all the outcomes. This one obviously is good. This one as well, because it was heads, heads, and then tails, is good too. So we'll color that yellow. This one is good because it was heads, tails, and then there were 2 heads. This one's not good because it had 2 tails. This one's good, so we will color it yellow. This one is not good. This one was 2 tails, and this was 3 tails. So when we look at it, we end up getting 1, 2, 3, 4. 4 out of 8. I think that drawing this probability chart can be really helpful for calculating this and knowing exactly how many. There's a trick for calculating the bottom number, the total number of flips. You can either just count the number at the bottom of your tree. The other way is that you can do it by just multiplying. So basically, you start with, okay, we have 2 options, and then we multiply by, well, there's 2 more options if we flip again, and then multiply by, there's 2 more options again. So that gives us our final answer. That was 8. Let's look at like a different example with dice. Okay. Let's say we're rolling 2 dice. So the first option is we get 1, 2, 3, 4, 5, or 6. That was our first dice. If we roll a second one, each one of these has a chance of getting 1, 2, 3, 4, 5, or 6. So you can see this chart is a lot bigger because there's a lot more options. So if we want to make our probability, what out of what? Let's say what are the probability of getting a double 1? So rolling a 1 and another 1. So if we look at it, that would be here, and then the first one was a 1. This would have been 1, 2, 3, 4, 5, 6. Okay, so if we look at all the ones at the bottom, none of the rest of them are going to be good. They're all going to be different. So there's only one possible way to roll a double 1. And then if we count, there's actually 6, 12, 36 possible options. Like we said, 6 times 6 more options, 36 for the total. Okay, so our probability of getting a double 1 is pretty low. If we said the probability of getting like doubles in total, then there would have been more, because there would have been like you could get 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. There would have been 6 out of 36. So that idea of drawing the chart and figuring out the probability like this is kind of the hard basic skill you'll need to be able to do in this unit. And that's the basics of it. A little bit long-winded, but that's it.